Hello everyone, welcome back to my channel. Today let's go over a hard question that I solved on my own. So I'm really happy about this. Wasn't expecting to do this given the acceptance rate. And I solved it without any help. So I'm really surprised, but we'll go over it. So basically you're given this integer array instructions and you want to create a sorted array from left to right. So you take these numbers and at each point you basically so we're going to start with an empty array, and then there's nothing in there, so nothing is bigger or smaller than 1, so you add 0. And then for 5, then that's the next element. There's only one element smaller and 0 elements bigger, so 0 is smaller than 1, so add 0. And then for 6, 0 smaller, so add 0. And then 2, there's 1 smaller, 2 bigger, so add 1. So you return the integer 1. And then you have to mod it. So let's go ahead and do modulo is 10 to the power of 9 plus 7. And I'll show you my initial approach, which got time limit exceeded, which was basically just to iterate over instructions. So left to right. And then, so we're going to start with a list that's empty, a sorted list, because we want them to be in order, right? So initially it's empty. So what we're going to do is do a bisect left, how many elements are smaller. Then instructions I inside of current, initially it's empty, and then how many elements are bigger than or equal to. So at this point, what we do is we add instructions of I at the end, and then we have an answer, which we're going to add the minimum of left and so right. So let's say we have a bisect right, you do the total length minus whatever the point is, because that's how many are bigger than. So for example, if you bisect right on here, you get with 5, then you get 1. So, or you get 0, 1, 2. 3 minus 2 is 1, so one element is bigger. So then you do length of current minus right, and then at the end you can just return answer modulo mod. So bisecting right and taking the minimum every time, how many elements are smaller, greater than, and then adding instructions I. So this technically works, but this is n log of n, which is too slow for this. So what I'm going to show you instead is, instead of just having this sorted list, we want to know where to add it in order, right? So if we want to add it for 2, for example, then we were going to bisect right is exactly where it should start. So before we do this, we're just going to say the position is what we want is bisect right inside of current instructions of I. And then instead of add, we're just going to insert at that position, which is like when we have 1, 5, 6, 2 is going to be at index 1. So insert at 1 instructions of I. So that gets rid of this is now just, it's better than a sorted list, because sorted list has to find that position. And I came up with this after trial and error. So, and there you go, passes all test cases. So it's not the most efficient, but again, solving a hard question on your own without any help is unusual for me. So I'm really proud of this one. So use the inbuilt modules and try to play around with it a little bit. And I think if you understand binary search, it's actually not too bad. So that's it for this video. Thank you for watching, and stay tuned for more.